Have you ever been playing any sports or running and have pain because of weak muscles or poor foot arches? Well, imagine being diabetic or being elderly and how much worse it is for them. This project was originally brought to us from a past research group that focused on learning how to measure the strength of the intrinsic foot muscles. The focus is to design the apparatus that would utilize a sensing method in order to accurately measure intrinsic foot muscle strength. So people with weak intrinsic foot muscles typically face lower leg pain, foot cramps, poor balance, which can lead to weakened self-independence. The goal is to find this accurate way to measure the strength in order to help people strengthen the muscle to improve their quality of life. A little bit about the biology of the foot. The picture on the left shows the abductor hallucis. This is controls the big toe movement of the abduction. So if you see my hands, they move outwards. The second is the abductor digit minimi. This moves the toe, the little toe on the outside, moves it away as well. The photo to the next, to the right of that, that's the flexor hallucis, and this pulls away the small toe, and then the abductor hallucis pulls away from the big toe, so they're kind of just all in the abduction and adduction movements. And these muscles, the dorsal and interplantar dorsal, right here on the right, those control the middle toes, and they spread the toes abduction in series with the adductor hallucis. So all of these are are kind of like combined, but they're all individual muscles, and they just move the muscles in and out. So all of them together kind of are responsible for toes and the flexure of the feet. They're very small muscles which control very fine movements, and wiggling the toes to control like side to side balance, and it becomes weak or damaged if um, they if you don't use these muscles in elderly and diabetics, they get really weak intrinsic foot muscles, which could also cause muscular dystrophy. Um, our project is different than many others because there's currently no effective way to measure intrinsic foot muscles by themselves without having extrinsic foot muscles contribute. Now, these extrinsic foot muscles are the ones that run along your calf and control the foot. It matters because elderly people who have trouble walking or have limited ability need assistance and will most like and like we know most likely know somebody affected by diabetes. So this makes them prone to getting ulcers. So in order to find a way, we've completed testing prototypes from a previous study done, and we researched ways to test the strength of these muscles and completed concept generation and selection. One of our main focuses was to split the design into two subsystems. One, pressure sensing and force sensing, and then a housing or finding a way to isolate these muscles in order to test them. The sensor system focused on pressure testing of the toes and getting a force output, while the housing focused on finding a test that gives us a most accurate way to most accurate results without using outer muscles such as the extrinsic foot muscles. So here we have on the bottom picture in the middle is the old prototype that we had benchmarked from the previous study. From this, we found drawbacks, including how it does not keep the foot in plantar flexion. And plantar flexion is when the toe is, it's kind of like pointed down at a 20 to 50-degree angle. It was also not sturdy enough to hold the foot and ankle in place to maximize the intrinsic foot muscles. And we also wanted a more accurate way, an easy way to read force output of the muscles through a sensor so that when we do bring it to somebody that wants to use it, they could easily read it and they don't have any problems with it. So we had found one thing that we wanted to focus on the sensor side was we had to use a pressure sensor with an Arduino board. The sensor that we decided to choose is a single tack sensor, which is shown there on the bottom right. We will use it to get an analog read output and then convert that into a force. To determine how strong the muscle will be is we're going to compare the force output from the sensor to control force that we will test with variable weights. On the housing side, the pictures on the left and the right, we plan on combining those two concepts. And the concept on the left is keeping the foot in plantar flexion, and that board will be adjustable to the comfort of the client that is using it. But keeping the foot in plantar flexion is important because that is a way to isolate only the intrinsic foot muscles without having the ankle and leg move. We also want to add straps in order to make it more to make the results come out more accurately so that they isolate the foot even more. Um, so overall, moving forward, we are finding the best way to include the sensor into this type of apparatus to provide human results and then start testing as well. So by taking on this project, we will gain more knowledge on what exactly the IFMs do, or intrinsic foot muscles, and how they work together to cause weakness in the foot. We are also planning on finding how strong they are so that we could help provide methods of strengthening clients such as diabetics and athletes and elderly so that they can be independent. Thank you for your time. We'll take any questions at this moment.